In this video, we will be going over exploration 2.4.1, where we are asked to find the inverse of a matrix. And the matrix we are looking at is matrix A, where A is a 3 by 3 matrix that is 0, 1, 2, 1, 0, 3, and 4, negative 3, 8. So in order to find the inverse of a 3 by 3 matrix, we will use this strategy where we will have the 3 by 3 matrix on the left side of an augmented matrix and the identity matrix on the right side. And we will make a goal to make the left side into the identity matrix while the right side will actually become the inverse. And we'll see that later on. Now, in order to achieve this goal, we can use something called elementary row operations. And elementary row operations allow us to switch rows, add or subtract rows, as well as multiply rows by a constant. So we will use these operations in order to achieve our goal. Okay, so I'm going to keep the elementary row operations at the top, as well as our goal, so that we can continue to refer to it. So let's begin with our augmented matrix. Now, in order to achieve our goal, we want this first top left term to be a 1. Now, in order to do that, we can use one of our elementary row operations. So I notice that there is a 1 in the second row. And since there's a 0 in the first row and a 1 in the second row, how about if we just switch those top 2 rows to begin? So when we switch the top 2 rows, we will get this matrix where the second row has now become the first row and the first row has now become the second row. Hey, so now we have 1, 0, which is great. And then the third term needs to become a 0. So in order to do that, there are multiple different options. But what I'm going to do is to take this third row and subtract 4 times the first row. So I'm going to multiply the first row times 4 and do the third row minus the first row. You are able to do 2 of the elementary row operations at the same time. So multiplying a row by a constant, as well as adding or subtracting rows, is completely fine. So when we do those operations, we will get this matrix. So just to do 1, 4 minus 4 times 1. So 4 minus 4 times 1 will give me 0. Negative 3 minus 4 times 0 will give me negative 3. 8 minus 4 times 3 will give me negative 4, and so on if we continue the row operation for the rest of the row. Now, let that we have our first column the way that we want it as 1, 0, 0. Let's look at the second column. We have 0, 1, and then that third piece, we want that third piece to become a 0. So in order to do that, let's use this second row in order to try to make that negative 3 into a 0. So we can do that by multiplying the second row by 3, multiply the second row by 3, and then add it to the third row. So 3 times 0 is 0. 3 times 1 plus negative 3 is going to be 0. 3 times 2, which is 6, plus negative 4 is going to be 2. And I'll go ahead and show the next matrix. 3 times 1 is 3, plus 0 is 3. 3 times 0 plus negative 4 is negative 4. 3 times 0 plus 1 is 1. So we end up with this matrix. Let's use a new slide. Okay, I'll bring back the matrix we just worked with. Okay, so now we have the first column as 1, 0, 0. The second column as 0, 1, 0. Now let's work with the third column. So the third column, it doesn't matter where you start, just do something that makes sense to you. So for me, I'm going to start with this middle 2. And I'm going to try to make that into a 0 by using another row in this matrix. So I notice that the third row also has a 2 in it. So if I just subtract the rows, let's do row 2 minus row 3, that should give me a 0 in that spot. So let's do that. So when I did 0 minus 0, I would get 0. 1 minus 0 would also get 0. 2 minus 2 would give me 0. 1 minus 3 would give me negative 2. 0 minus negative 4 gives me positive 4, and 0 minus 1 is negative 1. So that's how we get our second row. Now let's look at this bottom right 2 on this matrix. So we want that bottom right 2 to become a 1. So in order to do that, let's just multiply this third row by a constant. If I multiply this third row by 1/2, that'll give me a 1 in this spot. So 1/2 times 0 will give me 0. 1/2 times 0 will give me 0. 1/2 times 2 will give me 1. 1/2 times 3 will give me 3/2. 1/2 times negative 4 will give me negative 2. And 1/2 times 1 will give me 1/2. And you're welcome to do this with decimals. I just prefer fractions. Okay, so now we are very close. We have 1, 0, 0 in the first column, 0, 1, 0 in the second column, and 3, 0, 1 in the third column. So the last piece that we need to change is this top right 3. So we need to change that top right 3. And so the last thing we need to change it to is a 0. So how we're going to do that, let's use a similar strategy as we did in the first step. And let's take the first row and subtract 3 times the third row. And when we do that, we will get this matrix. So take a minute to check that and make sure you see how to do this elementary row operation. Okay, now let's look at our final product, our final matrix. We have our identity matrix on the left side and some numbers on the right side. These numbers on the right side, this is going to be our inverse matrix. So then we can rewrite this as A inverse equal to the negative 9/2, 7, negative 3/2, negative 2, 4, negative 1, 3/2, negative 2, and 1/2.